my desktop. I'm sharing my desktop here. But this I think it seems I can't share my desktop. So Java plugins I need. Thank you first of all. We again meet after a few weeks. Today's session is all about one of the wireless communication protocol. We have discussed about Bluetooth and wireless in the previous sessions. This is also a wireless communication protocol which works within the small ranges. Like you have you have works in the 10 meters of ranges. Okay, uh, you have Wi-Fi within few. Okay, 100 meters of ranges Wi-Fi works. But if you have devices very near to each other, very closer to each other, and you want high throughput, okay, you want high throughput. Devices are very close to each other so that they can able to see each other. Okay, if we have the line of sight, we will see what this line of sight is. Okay, so then in that case we can use infrared data association, IRDA. That is one of the wireless communication standard. First, we will see what is basically an infrared rays. Okay, infrared rays, where it comes in the wavelength spectrum. We have the spectrum, right? Where it comes in that, what is the wavelength and what frequency this communication will work on. Okay, so let's start with this one. So first, this is the agenda of our session. What we are going to cover in this. So it's an introduction to IRDA, then characteristics and key features of the IRDA, infrared communication standards, what are the infrared communication standards is, and how IRDA basics, then conclusion and future of the IRDA. Okay, so this will be the agenda of our session. So before going forward, I just want to ask that whether my voice and my video is very clear to all of you. Is my Am I audible to all of you there? Am I audible to all of you there? So my voice is clear. Is my voice is clear? My video and audio, and can you see the PPT which I am on? Everything is clear to all of you there. Okay. So we will be carry with our session. So this will be the agenda of our session: introduction and all these things. Okay. Then we will see infrared and communication. First, IRDA, it specifies a standard and a protocol for data transmission. IRDA is a standard which specifies a protocol for data transmissions. Devices which uses the standard communicates using infrared LEDs. So LEDs are light emitting diodes. Okay. So LED, LED light emitting diodes works on particular frequency. If we can change the frequency of the LED, we can change the color. Like if you're changing the color, that means we're changing the frequency actually. If you change the frequency, color will change. Depends on if you are in the visible light or if you're in the which range your LED is working on, which frequency your LED is working on. So if your LED is working in the infrared rays frequency, you can transmit infrared waves from your LED device, from your light emitting diodes. So the infrared wavelength is basically it's from 875 nanometers plus minus 30 nanometers. Okay, this will be the nanometer. This will be the wavelength. Okay, when you have the wavelength, you get the frequency, right? Because c speed of light is equal to frequency into lambda, right? C is equal to f lambda, right? So frequency and wavelength are inversely proportional to each other. So IRDA support data transmission of 1.15 megabits per second and 4 megabits per second. So we will see what kind of data rates your IRDA can support. Okay, so usually from when the standard 1.0 IRDA comes into the picture, we have 1.15 megabits per second, the first standard. Then the latest standard is having 4 megabits per second, the data rate. So this is the data per seconds we can transmit through this infrared communication. Okay. So, some history of infrared. 30 years ago, images were created by the crude temperature readings and simple recording devices. So they were using some this infrared for measuring the temperature readings and all those things. 30 years back, in 1980s, military have dedicated the first large sum of money towards infrared advancements. So this military decided to work on these infrared waves. So if you see the military equipments, they use this in the night. Actually, you can see by using infrared rays, you can actually see in the night also. The night vision equipments they started develop using this. So they started researching on these infrared rays, how we can use this in the equipments, how we can see in the nights, how so because yeah. So recently, scientists have changed the technology to focus on lower background heat and high sensitivity. It also, when you have the infrared rays, it will have some heat capacity also. So there will be a heat sensitivity also, and which can also fit for some of the applications which are needed for astronomy and all those things. Okay, so there are many utilizations of these infrared waves. You can use it for the heat. You can use it for the vision of the night, vision in the night. So there are a lot of applications of infrared. We will see what are the applications of this infrared and what how we can use this as a standard in our devices. Okay. So basically, why we use infrared? We use infrared for devices which are very near to each other, which can see each other actually. We can see each other. We use there. So what we will get out of this? So there is no need of wire connection. So your device, at least your device is not. If you have so many devices on the table which are connected through wire, it not seems to be good, right? Because those are connected to the wires. But if you want high throughput also, and you want wireless communication between two devices which are kept on a table, what you can go for? You can go for one infrared communication because it works on the light. Okay, it works on the principle of light. It works on the principle of frequency. So optical transceiver will be there, which will be transceiver is basically will have transmitting and receiving antenna both. Okay, it will transmit also transceiver. Okay, so in case of wire configuration, you will have host controller. Host controller is basically connected to one RS-232 serial communication protocol, serial communication port. Okay, RS-232 is one serial communication port, which is DB9, which will have 9 pins. Okay, that is connected to a wire to some of the device and sending out data serially. Okay, but in case of IRDA, what we are doing, host controller is basically sending out the packets to the one processor, one controller actually. NCP2120 is a microchip based controller which is sending out again the data bits. Okay, this controller will have all the encoding and decoding facilities because we want to transmit the bits on rays, right? So we want to first convert the analog signal to some digital form. So the encoders, decoders, encryption, decryption, everything which comes is a part of your this MCP21250 microchip, the chip they provide with, transmitted to the optical transceiver antennas, and then they will transmit through some infrared rays. So what we will achieve out of this infrared, why we are using this infrared, is enhancing mobility by easy wireless connections. Okay, so mobility can be increased, right? Eliminates connection cables. There is no connection cables. Then universal. This is a universal standard we can use along so many devices. It's a standard, so we can use out of every. If the device is standard, we can use directly. There's no point syncing or something else. So we can directly use that is standard is there in that device. So no transmitter interaction interference. So there will be no transmitter interaction and interference actually because it works in very low range. So your Bluetooth devices and your Wi-Fi devices cannot be interacted with this and cannot interference and cannot corrupt these signals. Okay, because directly you are getting transmitting waves and transmit rays. You will see how to transmit the rays. So it will transmit the rays with some angles. So it's like plus minus 15 degree of angles from the line of sight. You can see those rays only on the receiver side. So safe to use in any environment and easy regulatory approval, and obviously low cost is there. So these are some of the benefits why we are using this infrared rays. Okay. So what is infrared? What is infrared? Infrared is a certain region in the light spectrum, in the wavelength spectrum, and it ranges from zero point 0.7 micrometer to 1000 micrometer, or you can say zero point 0.1 millimeter. So if you see in this diagram, you have 400 nanometers to 760 nanometer is the visible light. So if some frequency is in this range, we can see these colors. Okay, we can see these violet to red colors. This is the wavelength spectrum for the visible light. This 760 you will have infrared. So as your wavelength is decreasing is increasing actually, okay, your frequency will decrease. Wavelength is increasing, frequency will decrease. So at the lower frequencies, your infrared is working actually. So it will work in kilohertz only. Okay. So yeah. So we will see what is the basic frequency of this infrared rays. Broken into near, mid, and far infrared, one step up to the light spectrum from visible light, and it's a measure of heat also. Infrared can also be a measure of heat because it will have when infrared rays are coming, it will have heat sensitivity also. You will feel something called heat infrared rays. Okay, visible light frequency will not be having heat sensitivity, but infrared will obviously having some heat. So yeah. So the basics of infrared is like this is once again I just want to show you exactly what is your visible light. Your visible light starts from 0.70 micrometer to 0.40 micrometer, in which you have red to violet color. Okay, Be below that if you go, you will have near infrared rays, and above visible light you will go, you will have ultraviolet rays, you will have X rays, you will have gamma rays. So there you have less wavelength. Your wavelength is getting decreased above visible light. That means your frequency is getting increased. So gamma rays works at the higher frequency. That's why we are able to penetrate these gamma rays. If the frequency is higher, it can penetrate to anything. X-rays can penetrate to our body, right? We can scan the body parts with X-rays. Gamma rays can penetrate to anything. So as your frequency will be increasing, your penetration level, your power will increase actually. Okay. So this infrared is less than visible frequency spectrum. So if you see the less than visible frequency spectrum, you have near infrared, which works from 1.50 to zero point 0.7 micrometers, and short wave infrared is from 3.0, and middle infrared is 5.50. Similarly, if you go less than that one, so you will get thermal infrared. Thermal infrared will having the heat sensitivity. This will actually will have heat sensitivity. So heat lamps, we use thermal infrared in heat lamps. So these are some applications like you see heat lamps you use thermal infrared, microwave we can use infrared, and short wave infrared also. Then AM radio we can use near infrared, television FM radio we can use this visible. Then microwave radar we can use ultraviolet. Okay, like this X-rays can be used by X-rays. So this nuclear atomic nuclear can use gamma rays also. Okay. Energy discharges from atomic nuclear is gamma rays. So very high frequency from nuclear atoms when they discharges the energy. This is something about the spectrum and where the infrared comes into the wavelength spectrum. Actually. Any questions regarding the wavelength spectrum? Any questions regarding wavelength spectrum where we actually find the infrared rays in the wavelength spectrum? Am I audible there? Am I audible to all of you? Any questions regarding this wavelength spectrum of infrared? Okay, we will carry on forward. So IRD, this introduction is like IRD is specified. It's a physical and protocol layers which is necessary for any two devices that conform to the IRD standards, detect each other and exchange data. So any two devices which wants to communicate to each other using IRDA, so we should have IRDA physical and protocol layers. So the physical and protocol layers is a part of your standard actually. We will see what this standard is all about, what are the IRDA protocol stack is from file layer to application layer, how it works. Okay. And the uses of LED and photodiode, what works as a which works as a transceiver, and it enables an extremely low cost implementation. LED is very cheap. Okay, LED are very cheap. So this communication is very economically extremely low cost actually. Okay, because LED and photodiode you can buy very less price. 1 rupees, 2 rupees, you will have get the LED and photodiodes. So if you have the data standards and if you can connect it, you can directly have the infrared communication between two devices. Okay, so uses of a single LED and photodiode in the transceiver enables an extremely low cost implementation, which basically works as a transceivers, these LEDs. So how data is encoded? Like data is encoded into pulses of infrared IR light. For example, your television remote control works in the same manner. Okay, when you press any buttons on your remote control, your IR light will go to the receiver side of where to the receiver side in the TV. Okay, so both the devices work on the same IRDA standard. So once you transmit some digits, it's being encoded, and then at the receiver side they will be decoded. So whatever the command you're passing from your transmitter, that will be again decoded at the receiver side. You're encoding it and then decoding at the receiver side. So and you're transmitting it at some frequency, which is your IR frequency. So IR frequency, your receiver and transmitter both works on the same frequency. So the communication can be done. So technology is suited to short distances with all devices within a room only. It is purposely designed to operate at about 1 meter, 1 to 2 meters, 1 to 2 meters it will work only. This gives IR security built in the stack, and no one can listen to that conversation. So since the range of the two devices 1 to 2 meters, the security is very high in this because no one can listen between these two devices the communication what is going on. Okay, so these are the data rates which are being provided by this communication. So as per the data rates, we have four communication standards. One is SIR, serial infrared. One is medium IR, fast IR, and very fast IR. Serial infrared, medium infrared, fast infrared, and very fast infrared. So serial infrared works standard. This is the standard 1.0, which works at 115.2 kbps, kilobits per second. Remember, kilobits per second is different and kilobytes per second is different. Kilobytes is capital B per second. Okay. Medium IR is 1.152 megabits per second and fast IR is 4 megabits per second. Now, in latest phones and cameras, if you see, when you say we have IRD communication, where IR facility is there in the phone, that is basically works on 4 megabits per second. Okay. In the computers, in the host computers, you in the like example, my Windows XP is having very fast IR, that is 16 megabits per second. Now they've start supporting it. So introduction is like the Infrared Association refers also to as like IRD. It's a non-profit organization who developed the standard is they are the companies collaboration which work together to manufacture some protocol. Why their protocol, they are manufacturing this common standard protocol? Because each and every device, if each and every manufacturer will have some other protocols, they are not able to communicate to each other, right? Because the devices, the one device can be of another manufacturer, another device can be the manufacturer. If both manufacturer agrees on some standard protocol, they can act okay. But if they are not supporting the same kind of standards at both the sides, then it will be a problem for both the manufacturers. So while they're creating this standard, there there is one non-profit organization whose goal is to develop globally adopted specification for IR wireless communication, and it formed in 1994. It due to the hundreds of corporate and individual members who volunteer their time and know how to continue development of IoD applications and specifications. So once you have the particular standard, you can develop your IRD application and specification depending upon the particular standard, right? So that standard is formed in the standard is formed. Now we will see till now we just see what is the history and what is basically your race and something some introduction about protocol. Now we will see the characteristics and key features. Any questions till now? We will see the characteristics and key features. Most devices available today operate at a maximum of 4 megabits per second. If you see the devices which comes usually here day to day, we have 4 megabits per second, and the range and the line of sight connection is at least 1 meter, but typically 2 meters can also be reached. Okay, this is how you can see in the diagram. Your transmitter is transmitting and receiver is receiving. Okay, so they will transmit and receive at certain angles. So line of sight is a center line. That is your line of sight. So from the line of sight, you have some deviations. You can have plus minus 15 degree of deviations in the transmitter side and uh, that deviation on the receiver side. So in this range, actually, if it can receive the transmitter, whatever the transmitter is transmitting. Okay. We can also create a wireless lens using this infrared. Like see in the diagram, you have laptops connected to the printer, another laptop, your camera, your phone, your iPad, okay, your phone and your laptop communication. These all can be done with this wireless communication. You can create a wireless local area network by using infrared rates. But the thing is, you should have a line of sight communication. If there is no line of sight communication, you cannot transmit the data to the receiver. Now, again, characteristics, there is some more characteristics. There is also a low version available with a limited range objective of 20 centimeter, but at 10 times less power consumption. So this is low power version, okay, which will work in the very range of 10-20 centimeter only. But the power, the 10 times less power consumption actually in this case. Okay, so these connections are suitable for point to point and even point to multi point also, depend on your your angle from your line of sight. IRD is very popular with portable devices such as notebooks, handheld computers, digital cameras, electronic books, toys, and watches. Your IRD infrared connection is established only by a directed infrared beam. Okay, so it will be established by a directed infrared beam for bidirectional half duplex communication. So now a question comes: what is your half duplex communication? So can anybody tell me there what is half duplex communication? Can anybody tell me what is half duplex application communication? Just want to check whether you're listening or not. Can anybody tell me what is half duplex application communication. At a time, only one device can send the data. Yeah, at a time, only one device can send the data. So half duplex means we are actually transmitter. If transmitter is sending, receiver will not send. If receiver is sending, this transmitter will not send. That is your half duplex. In this case, we are actually we are able to transmit and receive. Yeah. In case of full duplex, we can at a time we can receive and transmit. In case of simplex, we can just transmit or receive. We cannot do both at the side. So okay. Okay. So half duplex communication. So infrared basically works on half duplex thing. So if transmitter is sending, transmitter will transmit the beam. Receiver will receive it. If receiver is sending, receiver or transmitter will receive it. Okay. So that works at different times. So the lowest signaling rate here is 9600 bits per second. 9600 bits per second. That is the lowest signaling rate. When this negotiation, when they start the negotiation, when they start initiation of the transmission, that will this 9600 bits per second they will start communicating. Okay. Depending upon the depending upon what range they want to, if they want to increase the data rates, they can increase later on. But starting data rates is this only 9600 bits per second. To have the service discovery and to connect to establish a connection, you start with 9600 bits per second. Highest specified data rate which they can support is 16 megabits per second. That I already told you. It's a very fast IR. In very fast IR, they can use 16 megabits per second. Okay. Yeah. Now, this is something about what is your protocol layers. What are your protocol layers are. So we'll see the diagram first. So this is your IRDA architecture. Okay. IRDA architecture at the lowest side you have 5 layer. As I saw you so other architectures also, every architecture will have 5 layer at the lowest side. That the basic functionality of that 5 layer is to make a connection, to make establishment. They will have some addresses first of all. Your device address will be there in the 5 layer only. Okay, MAC, when you say MAC layer, MediaX layer, your hardware address will be in the 5 layer because they should know what device I'm communicating with. So they will send the address, then they will send the data. Okay. So 5 also determines the data bit rates. Okay. If I have 1.05 layer, another device is not is having 1.15 layer. Another device can support up to 1.5 megabits per to 4 megabits. But 1.05 device cannot support 4 megabits per second data rates. So the specification, data rate specification is purely managed by your 5 layer. If you this 2400 to 1.115200 bits per second only. If your 5 layer is 1.1 standard, it will support 1.152 megaseconds to 4 megabits per second also. Above that, we have infrared linked access protocol layer. So we will see what this access protocol layer is all about. And then third layer is your IRLMP management protocol layer, infrared management protocol layer, which will give some services, which will give some infrared access services actually. We will see what are kind of infrared access services it will give. And there is one more layer that is beside the IRLMP only, that is tiny TP. Above that we have IRCOM, IRLAN, IO OEEX. We will see these 3 things. IRCOM is for communication, IRLAN we want to communicate, LAN we want to connect, OBX is for some applications. There are different protocols for different applications. It's upon the applications also. If I am what kind of application I want to write, we will use different kind of ILP protocols at the third layer. Okay, but your first layer and second layer will be common for all the protocols. They are independent of applications. But the protocols which are at the third layer, like IRCOM, IRL, and IUEX, these are application specific protocols. Okay. So this is one more view. One more view of, like we can see here FIR, your fast infrared is gigabits per second, right? One serial IR, that is SIR, is 1.15 megabits, right? These are the 5 layers. Okay, 9600 to 1.5. This is one SIR is like this is one more. There are layers then. Okay, and then above that we have access protocol, and above that we have management layer. So management layer will also do multiplexing. We will see what multiplexing is, why we use this multiplexing, and then above that we have tiny TP, and management, above management we have yes, that is in infrared access services. Now that we have IRCOM, IR, LAN, OBX, these are application specific protocols. Okay, so now go back to see. Okay, so this is what I was talking about. So your physical layer, the functioning of this physical layer is encoding and decoding of data and transmission of the signal. It will encode and decode the data and transmit. IR access protocol. This is link access protocol, responsible for ensuring a reliable transport of data. And the management protocol, that's a third layer. Okay, that is, it will multiplexes services and application together to use one connection for transport. So if I want to use only one connection for multiple services, for multiple applications, we can actually multiplex all those applications sending out the data to one connection only. Okay, we have only one connection establishment between your transmitter and receiver, and multiple services and multiple applications want to use it. We will manage those with some kind of multiplexers at the transmitter side and demultiplexers at the receiver side. So your LNP will have multiplexers and the both these things. Okay, so we can also multiple applications can use one simple connection, single connections. Then IAS, information access service, it allows the capabilities and services of the device. So if you want to access the capabilities and services of the device, we can use with this particular layer, IAS. We will see in detail later on these things. So your IRDA takes a layered protocol specifying several layers of protocols, including your physical layer, your file layer, your lab layer, your LNP layer. File, lab, and LNP. Physical is lowest, then access protocol, medium, and then LNP management protocol, and the third one, which is application protocol specific. Okay. This is something about the other ones, yeah, application protocols. So this is about application protocols. So tiny TP, this is a version of transport protocol designed specifically for IR. Okay, flow control is offered ensuring that device buffers do not overflow, and maximum packet sizes are agreed by devices. Large packets can be broken into smaller parts. So you see, tiny TP is below OBX, COM, and LAN. So OBX, COM, and LAN, these are application protocols. But tiny TP is transport protocol. TP is for transport protocol. So like in TCP/IP communication, we have TCP, transmission control protocol. That is also a transport protocol where there is a formation of packets. Okay, how many what size of packets I want to form. So how much maximum packet sizes I can form. Okay, because what we are sending out to the network is packets only. We are transmitting the packets. On the packets we have bits, some sequence of data. So that will be decided by your transport protocol. Above the transport protocol, we have application protocol. Application protocol will take the data from the transport. So like IROBX is having object exchange protocol. So if we want to exchange some object from one device to another device, we will use this protocol. It allows the transfer for files easily between devices. Okay. Uh, Files transfer is very easy if you use OBEX kind of applications, OBEX kind of application protocols. And like IR-COM allows emulation of serial and communication ports. Okay, COM is for communication ports. So when we say IR-COM, it's an emulation of serial and parallel ports. Emulation means we can emulate your hardware ports. If I want to emulate some serial and hardware ports by using this, we can do that. If you use IR-COM protocol, application protocol, the application do not need to know that they are using IR, right? That's what we are calling it as emulation. When we say emulating the hardware, now application can actually talk to some ports, some serial port and parallel port, because that is already being emulated by IR-COM protocols, right? So that is one more feature of the this IR-COM protocol. Legacy application will work with this with this as a printer example. Like suppose if I want to communicate to my printer will communicate to some ports, right? So we can emulate some parallel port because printer is usually connected to parallel ports only. So we can emulate some parallel port, and using that parallel port, printer can communicate using infrared standard. Right? We use IR-COM application protocol there. Okay? And third application protocol is IR-LAN. So if you want to access LAN, if you want to create LAN, local area network for the devices, we can use IR-LAN application protocol. Mainly used to allow LAN access to a device which is already connected to the network, and also can access network also if we have a connection on the network. Okay. Any question till now? We will go to the detail of 5 layer 2 application protocols. We will go detail. Any question till now regarding this protocol? So your IRDA physical layer. So as I already told you, physical layer will have different file chips. Depends on the data rate ranges. Like if I have ranges from 115 to 00 bits per second, I have different file chip, different standard. 1.152 megabits per second, different file chip. 4 megabits per second, different file chip. Like this. So depending upon these different standards, you have different names also. Like SIR, we are saying slow infrared, which is 1.0 standard. It works 9.6 kbps to 115.2 kbps. Fast FIR, fast infrared, IRDA 1.1 standard, which transmit up to 4 megabits per second. Very FIR, very fast infrared, 16 megabits per second, depending upon the data rates. Okay. So this is first standard, that is 2400 to 115 to 100 bits per second. So in this standard, your links transmitter and receiver are basically designed such that they will be working in a line of sight only and point and shoot manner. So which will have 1 meter of minimum coverage with plus minus 15 degree of viewing angle. So in the previous diagram, like transmitter receiver, we saw the line of sight on the diagram with plus minus 15 degree of viewing angle, right? So it works like that. It allows a low cost and high data rate link to be produced in a small package. Okay. And based HP is your Hewlett Packard company, which is actually creating links SIR is developed for HP calculators. Okay. So and based of bytes of data from the processor are converted to a serial data stream by the UART. How communication happens in this case is like this. So you have your host processor which is connecting to the UART protocol. UART is nothing, it's a serial port, right? RS-232 serial port is there. like DB9, which will be communicating to some chip, which can be provided by your microchip, or HP can provide those chips, which will be implementing your encoders and decoder logics, circuit logics, which will talk to your transceiver. Transceiver is nothing; it's a LED device, right? Which can actually transmit and receive something. So we will have two things: LEDs for transmitting, and we'll use photodiodes for receiving. Okay, so combination of LED and photodiodes, we'll say that is. Okay, so in this case, we are just using host controller to UART to encoder, encoder to transceiver as 1.152 megabits per second. That is enough. Sorry, 2400 to 11. Now this is the second, which is 1.152 megabits per second. Okay, so in this case, we have high data rates. If we have high data rates, high throughput, we have to manage those packets. Okay, we need to have some buffers. So we need some frames. We need some framing buffers. So there is one more hardware which will be involved in this kind of chip, 5 chip. That's why, as I told you, that 5 chip depends on the standards and on the data bit rates. If you are having 1.152 megabits rate, your hardware will be different. How do the hardware? Your hardware changes like that. Your host processor, UART is already there, but you are actually communicating to the packet framer. Packet framer is one more hardware which will actually frame your packets. Okay, here data hypothesis higher than the previous one. So you need one more hardware to resolve the problem. It needs some more buffers. Okay, so packet will be framed in this packet framer, and then they will be sending to the encoders and decoders to encode those packets, and then they were transmitting by the transmitters. Okay. Now this is the in third one, that is 4 megabits per second link. We need another, that is your phase log loop. One phase log is edge detection, which will actually replace your edge detection as the means of recovering the sampling clock from the received signal. So what is basically a phase lock loop is, it will generate some frequency, it will generate some clock actually. Okay, depending upon the reference receiving frequency, it will generate its own frequency at the receiver side. Okay, so to sample out the received signal and to recover the sampling of the received signal, we will use this phase log loop, another hardware in the receiver side. So what we will do is, your phase lock loop will get some reference frequency from the receiver side, and then with that frequency will actually code and decode the data. That will be faster actually. If you want to make our data rates faster, previously that job was done in this encoder and decoder chip only. But now what we are doing is, we are actually taking the reference frequency from the receiver of the transceiver side. We will give the frequency to the phase lock loop circuit. It will actually detect the edges where we have the sample, where we have the samples. What is sampling means? Sampling means we are actually sampling out some analog signal to digital signals. Okay, what these encoders and decoders will do, that they will do that only. Okay, they will sample out the signals. So with the help of this phase lock loop circuit, we are actually able to fastly sampling out transmission. Okay, sampling out the signals. So with this extra hardware, phase lock loop, and packet framer is already there. Okay, packet framer we already have. Now we have added phase lock loop to have more higher bits of communication. So it will. So now in this case, we will have 4 megabits of data communication we can have in this 5 chip. So this 5 chip has another hardware. So all the 3 chips, 5 chips are first one is not using any kind of packet framers, using encoders and decoders. Second one have used packet framer to handle more buffers, to handle more packets, okay, to frame the packets. The framing packets job is being done by the packet framer hardware. Then again, to increase the speed, we again have one more hardware in the third, that is phase lock loop. It will actually take the frequency and then encoding and decoding faster. Okay. This is your packet format. So for any protocol, for sending out any data packets, we have some frames, like for Ethernet frames, wireless LAN frames, Bluetooth frame. Similarly, we have IR frames also. So if we see 4 megabits, this is the frame. Like preamble is the starting 64 cells, then start 8 cells, then frame body where we have actual data, CRC. CRC is nothing, it's a cyclist redundancy check. So if you want to check some parity checks, like if you want to check the errors, okay. So in transmitting the packets, in transmitting the bits, some error can occur, okay. At the receiver side, if you're we can actually check this redundancy check, and by checking this one, we can actually see whether the bits were corrupted or not. Okay, there is some to be doing this CRC check also. So we need to send in each packet format, we need to send 4 bytes of CRC check bit rights. And last is stop, that is 8 cells. So this is one packet format. Any questions till now regarding your 3 hardwares, 3 5 chips? Any questions from the team? Okay, we will forward if you have not any questions. So now, till now we've discussed about the 5 layer. 3 types of 5 chips we have discussed about. What kind of hardware we have in that 5 chips. And what is the difference in the chips. Now we will go to our second layer of the protocol step, that is your infrared link access protocol. So it's a infrared lab protocol. So IR lab is the IRDA protocol that provides the basic link layer connection between a pair of IRDA devices. Okay, one pair of IRDA devices, a receiver or transmitter, if you want to connect, we need some linking mechanism. Okay, so it's same like MAC layer in wireless, MAC layer root. So here we have access protocol layer. MAC layer is nothing, it's a medium access protocol layer, right? Where we actually the medium we are actually carrier sense multiple collision. In those medium we are sensing it out, seeing the bandwidth, we are seeing the which band is free. Okay, so we can transmit and data. Okay. That stuff is being done taken care by the LAP in this format, in this protocol. It provides functions like connection establishments. Suppose connection establishments and the data transfer role. We want to control the flow. Okay. All these are the functions of your lab. Link access protocol. IR lab provides a mechanism for ensuring contention-free access to the medium, at least during data transfer. So this is also responsible for any errors comes into the picture. Okay, this will also take care if any device is interfacing, or you can say corrupting the bits. Okay. So this will take care. This layer will take care of that. Now the next layer is infrared link management protocol. It's that is your third layer. Okay. Link management protocol is there on top of access protocol layer, and it has two main functions. One is application and service. discovery. Application service discovery. Second is multiplexing of application level connections over the single IR-LAP connections. As I already told you, this layer will actually take care of multiplexing of applications. If multiple applications want to use a single LEP connection, they can use that. They can do that. Why? Because management protocol will take care of that. Okay? If three applications wants to have communicating with with one connection only over a single IR-LEP connection, they can do that because we have multiplexers and demultiplexers placed in this particular layer, link management layer. So there are two functions. So one is application service discovery and another one is multiplexing. Now, what is application service discovery is all about? So IR-LNP layer allows individual service user applications to connect and exchange information with similar entities in the peer device. Okay, peer device is the your independent of any other service users that may be using the IR-LNP connection. So any individual service or we can say application can connect and exchange information with similar entities. Okay? And we can talk to the other device. So two main functions provided by IR-LNP are between two sublayers. Okay? So as we discussed just now, we have two functions provided by LNP layer. So that will be divided into two sublayers. One is management multiplexer layer, that is called LMMUC, and another is link management information access service, LMIS layer. Okay, we have seen this LMIS sublayer of LMP layer in the protocol step, right? At that fourth, besides the application protocols. So link management multiplexer for multiplexing or for communicating with with multiple applications on a single connection, we can use this one. And for services, accessing the services, we can use link management information access services. So your LM multiplexer, it's how it will do that. Your multiplexer is, so what happens is it will add 2 bytes of overhead, means overhead data. So it will add 2 bytes of extra data to the IR-LAP information frame, which are primarily used for addressing the individual multiplex connections. Okay, so that 2 bytes of overhead extra information which is being added to the LAP information frame is actually used for addressing the individual connection, right? If we are multiplexing 5 or 6 applications to one connection, we need to find a way so that we can actually demulti this thing in the receiver side. How we can do that? What we do is we will add 2 bytes of overhead data to the IR-LAP information frame. At the receiver side, in the demultiplexing, that is the sublayer of your another management protocol, we will use those 2 bytes address. If you will see, that application will actually see if that address is for that application will take the data. It's similar to like we have transfer ports, okay? Transfer communication ports. So like 80 is a transfer port for HTTP application. HTTP application will only listen at 80 as a port. So this is one information which is being added into the transfer protocol layer. Similarly, we are adding some 2 bytes of overhead data to the IR lab information frame so that the receiver side actually can demultiplex and the application can actually see, okay, this data, this frame, this packet is for me because the address is related to me only. Okay, this is how with the help of with adding these 2 bytes of overhead data, we can actually multiplex and demultiplex so many applications working on the same connection. This is one good advantage of the protocol. So here address fields uniquely identify the service access points. Okay. Service access points is the service access points is for application. Okay. At both the source side and destination sides, by using these address fields, they can uniquely identify their identity. Okay. So this is what about your multiplexing, link management multiplexer, which is being provided by infrared link management protocol. Any questions? Any questions your side? So this is about multiplexing different two main applications on a same single connection with the help of these 2 bytes of address, 2 bytes of extra data, 2 bytes of address and data, which is obviously overhead, but at least we are able to communicate too many applications on one single connection. Otherwise, have different connections for different applications. So now this is the second sublayer. Second sublayer is about your information access service sublayer. So second sublayer is your link management IES service layer. Link management information access service layer. Okay. So what is the functionality of this one? The information access service maintains information about the services provided by the host device and provides services that allow access to the information base on the remote devices. So what happens is, remote device, you can say if you're transmitting something to the another device, you can say another device is a remote device, and if you want to access some information on the remote device, okay, you can use information access service. It's like a database which is already been there in the your first device. Okay. Now, if you want to use some services from a remote device, you can do that with this protocol. Your information access service maintain information. It will maintain some database about the services which are being provided by the host device. Okay, and it provides the services that allow access to the information based on device also. So, services means like email. Okay, these are the applications. These are the, you can say, these are the services. If I want to use email service from the remote device, we can use that with the help of information access service, this protocol. So this information access service, it allows devices to discover which services are available on the host device. Okay, so with this, actually with this layer, we are able to discover the services which are being provided on our device. Like if I have email capability, if I have calendar capability, if I have timing capabilities, services if I have on those device, I can discover those services. Once I have discovered those services, I can actually send the services to the remote devices. Right? So the transferring of these services from host to remote and remote to host is being taken care by this sublayer of this link management protocol. Okay, information access services allow device to discover the service. That is what it is saying. So this ends your understanding of IRDA protocol from file layer to management protocol layer, and above that we have application protocol layer, which I already discussed, like LAN, your COM, which will emulate your serial and parallel ports, and your LAN, your COM, and like OBX. It will transfer the objects. Like if I want to transfer some files from device to from host device to remote device, we can transfer that if we have OBX protocols, application protocol in place. Any question till now regarding this IRDA protocol stack? Any questions you can ask about this? If you have any questions, you can ask me. Now we will see some transceiver and receivers, like we are saying have LEDs, and so there is one called, so it's an infrared phototransistor. If you see its data sheets, you will have TSOP 1738 is the device name. TSOP 1738. It's a phototransistor. So phototransistor means photodiodes, like it will receive. Okay, so it will be used for receiving the IR rays, receiving the infrared rays. One pin is V out, one pin is your ground, and one pin is VS. Okay, VS is actually the source, then ground, and then out. Okay? So TSOP one is a 3-pin device that receives the infrared burst and gives out the demodulated bit stream at the output. So output means at the receiver side, if you will connect this TSOP 1738 phototransistor, we can actually receive the IR rays, and it will convert that into demodulated bit stream at the output. Okay? This is how we can actually, this is the block diagram, a little block diagram. The receiver side, what happens, to transmit something through IR rays, your this is your photodiode. Your photodiode means you are some light is emitting on the diode, then there will be there will be some changes in the diode, in the current and voltages, right? You know for how photodiode works in reverse bias and forward bias, all those things you should be knowing. Okay, so if light is so light emitting means LED will actually transmit the IR rays. So that is your light emitting diodes. Photodiode means your light is transmitting diodes. That it will change in the your electrons will change, and your voltage and your current will change. Depending on the change, you will get some input. That input being given to the AGC, that's your automatic gain controller. Automatic gain controller will decide what gain I need to adjust that particular inputs. Then you will have some band pass filters to filter out the noise parts of the receiving signal. Control circuit will control all these AGC, band pass, and demodulators. And after band pass, we will actually demodulate the signal. And after demodulating it, we will have transmitter. Transmitter will actually uh, works. Demodulating means digital signals to some analog signal. Analog signal will actually run your transmitter to generate some output signals. Okay, so from the collector side of your transmitter, you will get the outputs. Ground is connected to your emitters. So VS is connected to a power supply, and that is 100 kilo ohms of pull-up. So pull-up resistance, which is basically connected to your plus 5 volt or plus anything like which device is working on. So pull-up resistance is connected to your DC supply, positive supply. Okay. So when your transmitter is switched on, you get 1 at the output. When your transmitter is off, you get 0. Like that you can see. So whatever the bits you will see from the outputs of the transmitter. So this is one example of your Philips RC5. RC5, it's IR5 IR infrared protocol standard they're using, which is called Philips RC5. So it's RC5 core they have. So most audio video systems are equipped with an infrared remote control. Okay, the common mode standard protocol for IRD communication is RC5 core, which is originally being developed by Philips. So if you see in your televisions, RC5 codes over there. So this code has an instruction set of 204 different instructions, and it is divided into 32 addresses. You can read about it, how it works, how your TV IR remote controls. So they will have their own addresses, they will have their own commands which they want to send to the receivers. Receiver will understand those commands and will reply back to the particular command. Okay. When we press the buttons will give some signals. Signals will transfer to some IR rays. That will be received by the received signals. Then they will be demodulating. Demodulator will take that and will pass the address. It will see what command it is, and then it will again transmit to the transmitter side. That's how communication works here. So transmitted code, the data consists of 14 bits, is defined as in which we have two start bits for the automatic gain control in the IR receiver side. One is 12 bit that is changed every time when a new button is pressed on the IR transmitter. Whenever there is new button pressing on transmitter side, toggle bit will come in picture. And 5 is the address bits for the system address, which system we are talking to. So we need some address bits also. So for that we are using 5 address bits and 6 as the instruction bits. What instruction we are actually passing for the press key. Like if I pressing some key, if I want to pass some command, that command will be in the form of bits only. So 6 are used for instruction, are used for commands here. In case of TV remote controls. So the total frame looks like this. So if you see, the total frame is 14 bits. Okay. The carrier frequency here we are using, IR carrier frequency we are using 36 kilohertz. Okay. So at this particular frequency we are actually transmitting the data bits from the transmitter to the receiver side. One bit, the duration of one bit is 1778 milliseconds. Total amount of this from start bit to stop bits, we have 2489 milliseconds. So in this duration, we are actually able to transmit one command bits. You can say that. In 2489 milliseconds, we are able to transmit one command because it is working on this particular carrier frequency, 36 kilohertz of carrier frequency. Any questions? This is one of the example actually. I've taken one of the examples how actually transmission works and how what are the data rates. This RC5 command, this RC5 packet code, or you can say code frame, is basically used by Philips for their remote controls. If you want to control the send some IR waves to the receiver, they use that frame actually. It's a 14-bit address frames. These are the advantages and disadvantages of infrared. You can figure it out now because advantages obviously point-to-point communication. First of all, first line of sight, we have good line of sight here. Transfer data up to 1 meter. Security is there actually because there is no interface, no other device can come in between these small ranges. Low power consumption, low cost obviously. Device low cost because the LEDs and power diodes are very low cost. Okay. Disadvantages. Disadvantages line of sight. First of all, line of sight is a disadvantage also. Line of sight sometimes becomes advantage also. Okay. So one device at a time, transfer rate 4 megabits per second, and have to keep the device stable when transferring data. Okay. So we need to stable the device when transferring the data. Since right here we are able to have the high throughput also. If the line of sight, we can achieve the high throughput also. That angle, that reception and transmission, those angles, if that any device comes into that particular angular tolerance of that line of sight, we can actually transmit high data. And more devices also we can communicate with if we are able to do that. These are some applications, your IR applications like in PDS, personal digital assistants, we can use IRDS, IR applications. Phones, we can use an organizer, we can use in printers, cameras, laptops, notebooks, and there are very other applications also. So this ends to my lecture of IRDA protocol. If you have any questions, you can pass those questions to me. You can answer those. We will be taking questions to 5 minutes. Let me know if you have any questions. This ends up my IRDA session today. So I've just enabled the download option for this one. You can download the files. Let me know if you're